So, in the last class what I gave, I told you that what is the aim of this course, what we want to do throughout this period, and also we told that different types of biometrics system we like to discuss, right. And it is already told that we need to know little about the image processing, and I know, I understand that you do not have the background on image processing, but again I am not going to cover the total image processing things. Whatever I need throughout my biometric system, that part only I will be covering. Otherwise itself is a course, so I do not want to cover all this. Now, I mentioned that what is image, right? Image is representing a certain picture or some photographs, and once you think about the picture or photographs or something like that, automatically it comes to your mind, it is a two-dimensional picture. Now, the two-dimensional picture means what? It is a two-dimensional array, and once it is an array, what it means that it gives you m cross n elements, right. Now, each element represents to some part of your picture. Now, if I tell that it is a 100 cross 100 image and it is representing that 1 kilometer by 1 kilometer area, then obviously 1 pixel represents to 10 meter by 10 meter or something like that, right. So, that 10 meter is a big number, even though you feel that the 10 meter is very small, but 10 meter by 10 meter means 100 square meter area is representing, right. Now, one thing you remember that if I go for the satellite image or remote sensing satellite image, it is covered from the say top of say 250 kilometer, and it is giving the image of say 100 kilometer by 100 kilometer. So, 1 pixel is representing some things. It is assumed that it obeys the normal distributions, or if there exists a greenery, it will be suddenly the greenery will not be restored. So, greenery is a certain area you will find green, and then again there is a transition with the green and urban area, again you will find that certain area is urban and so on. Now, if I think that no 1 pixel represents to 100 kilometer by 100 kilometer, obviously you will not see anything, right, because it is a green plus urban, everything will be in 1 pixel. So, this image we stored it in the two-dimensional array. In the case of fingerprint, it is a very small area, but I am telling that it is 500 ppi. 500 ppi means 500 pixels per inch, right, 500 dots per inch. Sometimes you tell dpi, sometimes you tell ppi, dot per inch. So, it is a big number. So, it is a highly, full resolution is very high. You can see every minor points in your fingerprint image, right. But there exists the 1000 ppi fingerprint scanner also. So, it gives a bigger image, right, and every small things also you can see. Now, how can you collect this image, right? One way is that through camera. This is a simple way you take the camera, and then you have the different types of scanners, right? Flatbed scanners are there where you scan it, right? And that third one is the coordinate measuring units. Have you seen tech plot type things? Have you seen those type of things? That in the civil engineering department, people what they do, they want to draw the maps, digitize the map. What they do? They have a pen, digitized pen. It puts on the map, and automatically the coordinates are getting stored, right? And obviously there exists certain error, because human being, whenever you are fixing a dot or using the digitized pen, it may not be exactly on that, but error will be very minor. But this is another way you can digitize your whole map. So, one is digital cameras, and that is if you go to the market to purchase a mobile phone. See, have you ever recently visited any mobile shop to purchase a mobile phone? You have visited. What they tell about mobile phone? So, they will not talk about the phone characteristics. They will talk about the camera characteristics always. It has or music that this much capability it has, you can store these. Not they don't talk about the phone. They talk about the camera, that 5 megapixel, 10 megapixel camera. Now, why they are telling about this one? Because they want to make use this system for multi-purpose, right? And better the number of megapixel, you will get the better is the quality of the image, because more dots you are putting in one small area. So, this is an image, and this image, as I told you, but do not think that that much size pixel will be given, because pixel size will be very small neighboring area, but I have for visual point of view, I am dividing into the grids and assume that this is 1,1, this is 1,2 and so on. Now, how does image being read? See, generally image you are reading from this one way could be like this, the raster scan method, right, this way. One could have thought, no, I will read from this way, right. But another way one can think about doing this way. But generally we read from this corner and read from the left to right, right. Now, how to read the image? There are standard image processors, those who know that OpenCV, their straightway image read routines available, or MATLAB image routine. So, we are not going to discuss how to read an image, that part you read yourself, that OpenCV you can take the help of OpenCV or you can take the help of MATLAB. For us, it is a matrix A or matrix I, where Ij is telling about or pointing to the pixel at the ith row at the jth column, right. What if I tell Ij, this is the ith row, jth column, this element I am looking for. Now, types of images, there are generally 3 types of images. One is known as binary image, another one is grayscale image, and finally color image. And most of us are habituated with the color images, right. Yes or no? But why color image? Color image gives you the better soothing effect, right. But or you can visualize the texture or color complexion part more better way. But most of our algorithms will find that we ignore the color, right. We are dependent on the other 2 methods, the other 2 image representation, because that color, today you are coming with the normal color, and tomorrow you can put much that telecom powder and other things, that the color will be different, right. So, that color will not play major role in determining or using the system for identifications. Now, what do you mean by binary image? Name itself is telling you that it has the 2 numbers, right, that each pixel intensity means value, that as I told you in the image, it is a I cross or m cross n, and ijth element is represented by ij, that contains one value, that is either 0 or 1, right. That is why it is known as binary image. And sometimes we tell is a bi-level or 2-level image. Since it contains only the values 0 and 1, or each pixel represents 0 or 1, so I can have 8 intensity values in one byte, right. Or we can take the help of bitmap to represent the whole image, right. Once I have the bitmap, or once I have the 8 pixel values in one byte, so I can use the bit operations, right, to perform any operations on the image. Now, where are you going to use this binary image. First thing is that you remember that binary image is useful while we use as a mask. Mask means there is a small image I want to move throughout the whole image. We will see when we will be performing the certain operations, we will be using that as a mask. Sometimes binary image comes out as an output of the certain operation on the image. For example, that suppose I want to see only the edge of image. What is the edge of an image? Suppose I have a house here and here is the path, and this I don't have to see the color of this or the texture of this. I want to see that boundary of this or the boundary of this path or boundary of the railway tracks and so on, right, or the river. So only I need to know the line to see the bank. That is useful. So you need, these are all zeros and this I put 1, then I can see this is a white, right, 0 and 1 itself sufficient to represent your edge. Similarly, for our case also what happens that I have say I got my hand like this and I want to segment each fingers. I want to segment each fingers out of this. So to segment it, I need only this area. I don't need to see the inside of the things. I need to see this part, I need to see this part and so on. So to segment something, that binary image is very useful, because if you perform the operation on other image, it will take huge amount of time and you may create a lot of problem. See, for example, this is your binary image. You see the sharp difference between the 0 value and 1 value pixels. Whereas it is the grayscale image, here the values are not 0, they are having certain other intensity values. That is why it is, shade is different. So is it okay? So you know now what is binary image, and you have just heard the term grayscale image. What does it mean? In the case of grayscale image, each pixel is represented by 8 bits. That means a byte is allocated for a pixel in a grayscale image. And it is, of course, that remember one thing, that intensity value of each pixel is a positive integer. The intensity cannot be negative, right? So the number obviously lying between 0 to 255, because 8 bit, right, and each bit will give you some information about the intensity. So value 0 means that it is very dark, and value 25 tells you, value 255 tells you that it is white, right? And in between the values, that is telling you the texture shades of your images. So if we go back to this image, this is a grayscale image. Now here the value is 255 or nearby values, exactly may not be 255. This area you may get it is near 0, and here you are getting some shades, right. So the values, this is near 0, these values need not be 0, these are maybe 55, 60 like that values. You understood? So then the grayscale image, the intensity values will be lying between 0 and 255. So this is an example of grayscale image. Now obviously another term is coming, the color image. The color image is composed of the 3 components. One is red, green and blue. We tell RGB, right? And each of them is having the same as the grayscale values, lying between 0 and 255. And if I combine all these 3 factors, then you can visualize the color effect, right? One of them will not give you the color effect. Now how to represent, because there are 3 parts, one is R, another one is G, another B. How are you going to represent this? There are 2 ways you can represent. One is the whole R part is there, then G part, then B part. So R image, G image, R image, then followed by G image, followed by B image. Then when you want to combine, that you take this pixel and this pixel, show it, display it, then take this pixel and this pixel, display it, and so on. Right? This is one format. Another format is that I have R, G, B, R, G, B, and so on. So, R component of the first pixel, G component of the first pixel, and B component of first pixel. They are kept together. That means 3 bytes I am keeping for each pixel. So that's why it is written at M cross N cross 3, right? And this is mainly used for your color display. So this is a pseudo color basically, that is artificially on the same, I have put some color and to show you, it's a pseudo color. Now once I have an image, you need to perform some operation on the image, otherwise what for you are representing that image, right? Say for example, that satellite sends you the data, you got an image, and that image, satellite is what? Satellite is moving, and here is the satellite, and it gives you this is the path of the satellite, and it gives a picture of this path, whole path, from here to here. Now handling such a whole path at any instant of time will be very difficult. So what we do, we divide into the frames. So this frame has to be taken into account to analyze, right? Now you observe that it contains several problems. First part is that once system is giving you the data, it has different types of distortion. So you need, for example, the distortion is that while it is sending the data, earth is moving, or earth curvature is there. So all those, or satellite behavior is an issue, right? All those, because you should not think the satellite will be moving like this only. It may move like, it has a lot of tilt, all those factors will be coming. So those corrections are required to make, so that you can visualize the image. It may so happen, suppose the satellite is a CCD based, CCD camera it has, say you have say 2048 say CCD lights are there, and one light is not functioning well. It is not giving it is not making it on and off. So what you will get? You will get one dark line, because this is always, it will not give you any image because that light is not on, right? So if there is a line here, dark line, you will not be able to sell your image. Nobody will purchase your image if you tell that my satellite is not giving you the whole image. So you need to do certain operations, or it may so happen that because of some reasons that some noise enter into each image. That noise will be there, because for any image you cannot think that you will have an image without any noise. But that noise should be as minimum as possible, so that you get the soothing effect. People will purchase your system. Otherwise, if it is full of noise, nobody will take your image. So this, after getting an image, you need to perform some transformations to transform the original image to the output image, and that is coming under these operations. So one thing is that there is a point operations. What it means, that I have an image, and each point I have to change by some value. Each point means each pixel representing the certain position of the image, and it contains some intensity value. but you need to modify this intensity value, right. So, this is a point operations. So, for example, what happens that even though I am thinking that in a grayscale image, the intensity values will be lying between 0 and 255, but in reality it may so happen that you are getting the data lying between 60 and 120, because there is no guarantee the system will give you that intensity value 0 to 255. You will be getting say 60 to 250, 120. Now, you want to improve your contrast. You want to show that no, it is covering the whole range. So, you need to do some operations on each pixels, right. That is your point operations. Then is coming local. This operation is different from the point in the respect in this following respect. To compute or to estimate this pixel's intensity or to obtain some operation or performance on this or intensity on this, I will take the help of some neighboring pixels. Okay, I will take the help of some neighboring pixels to obtain some intensity value of a pixel. So, that is your local operations. Finally, the global operations. The global means that whole image I will be studying to draw some conclusion. Say for example, I want to know that what is the intensity range. So, I will read the whole image and then I will tell that minimum is 60 and maximum is 120, right. So, this is a global operations. So, these are the three types of operations we will be performing, and since we are working each pixel, mainly we will be working on the each pixel. So, our work will be mainly on these two parameters, because generally this is only to draw some conclusion, to tell about the image behavior, image quality or something, what is the contrast of the image. For that type of things we perform this type of operations. Now, once we think about the local parameters, that local operations, so the concept is coming the neighborhood. What do you mean by the local? That who are the people, they are neighbor of a pixel, right. So, you have say for this image, suppose this is any pixel, suppose this is a pixel, and who are its neighbors? One neighbor could be these four things, they are known as 4 connected neighbors. Okay. Now, another one is that 8 connected. Right. These 8 are neighbor of this. See, you can think those, I want to consider another level to have the neighbors. More you are increasing the size, more you are making the size, complexity will be increasing and you will not gain much. So, to estimate this pixel, if I consider these 8 neighbors, what it will give? That behavior of 8 neighbors, you are taking into consideration to estimate the intensity value of the central pixel. That is the idea. That if I consider the 4 neighbors, to estimate this, I take the behavior of these 4 neighbors. I take the behavior of this, behavior means I take the intensity information of these 4 neighbors to estimate the intensity of the central pixel. Is it clear? Why it is so? So, for example, as I told you, the remotely sensed image, I always feel that the behavior of the intensity levels of the neighboring pixels will be maintained. What it means? Say for example, here this is the green shade is there. If you consider the neighboring pixel, that also will be the green shade. If there is a major change in your path, say this is a path, there is a major change between these two, right? Then it will not be one pixel. It will not be, it will be suddenly it will not be there, because it will be soothing impact will be there. That sudden change will not be there. Slowly it will be changed. So that behavior of the neighboring pixels, will help you to estimate the pixel value of this one. So one way, say for example, I have one CCD light is off. Now this is, I have to estimate this value. What I will take? I will take the behavior of the two neighboring pixels, and I put an average value of this here, right? So the dark becomes, the behavior of these two have been taken into account, and I get the soothing effect. Now if it is a sharp change here, you will not get the sharp change, because you have taken the help of the 4 neighbors or 8 neighbors and to estimate the intensity. So there will not be sharp change, there will be some soothing things. That is the only possibility of loss of some information, right? So this is 8 connected and 4 connected neighborhoods. The next one is that this will be very useful for estimating something, estimating the output image. Say what happens that you have got a satellite image here, right? Now this image has full of distortion, and you have corrected them. So once you correct them, so this point I will be discussing, while we will be discussing the geometric transformation, you will find that this point will be, this is your input image and this is your output image. Now this is the grids of the image. Now these corner points, once you do the corrections, it need not be this point, it will maybe here. This point need not be here, this may be here. This point need not be here, this may be here, and so on. But see, this coordinate has been, say 1, 1 has been moved to say maybe 1.5 and 1.7, maybe. It need not be the integer, but these grids are in integer, right? So you have to get the gray value or intensity value of these integer points of the output image from the input image, original input image. You understood? So you need to do some operations to get the estimated value of the output image on the integer grids, not on the real grids. Because real grids you will not be able to visualize the thing, because these points are integers. Is it okay? So that is your resampling. We will be discussing while we will be covering that geometric transformation. So this is your neighbors. Now that operation of the, this is not actually word global, this is the point operations on the whole image. Global point operations on grayscale image. First one is clearing an image. This is the initializations. I want to initialize an image by a white intensity value. White means 255. So for each pixel I am putting it 255. So this image becomes snow type things, or it contains the white values. I want to copy an image from J to I. So because here I am assuming that you have already read the image. Next one is I want to invert an image. What does it mean? That I have the grayscale image, I want the negation of that, because negative image is sometimes very useful. So what we do, we subtract each element from 255. That will give you the negative of your image. The negative of image sometimes useful. For example, I want to see whether there exist some dots or not, right? Say for example, on your iris you have the black, and inside there is a small area, another dark, very dark. If you see that in your iris image, this is your eye, and this is the dark area, and inside that there is a very small dark area is there. I want to get that small dark area. If I do the negate of this 255 minus this value, this will become very white. Right? The small area will become, this will become almost 255, and rest this may be 200 and so on. So this area you can visualize that this is your pupil area. So I need to get this part. So if I know this area, I know the centers, I can find out through circle expanding, and I can obtain the outer range of outer part of your black area. So the inverting an image is a very powerful operation for our case. Sometimes you need to shift the image towards right, towards left, and so on. So I am shifting the image towards your left. So similarly, I am shifting the image up, and now next one is that I want to increase the brightness of an image. How to increase the brightness? So simple operation is that I just add some value on each image component, each pixel, right? Say I have the intensity value x, I add alpha with that, and you will be getting. So what I am doing, the intensity value which was lying between 60 and 120, and I am adding now 30, so intensity level will be, range will be 90 to 150, just I have added. Now while you are doing these operations, you must ensure that it must be less than 255. If it is more than 255, you are in problem. Then it will take some negative value because it will be overflow, right? So you have to ensure this part. Now little more that no, I don't want to increase the intensity level by 30. What I am doing, that I want to stretch it, I want to expand in different ways, that is so that not only it is shifting, it is also stretch in all respects. So I am multiplying by a multiplier factor and plus 30 movement if I want. This value should be less than 255. So if the number was like intensity value was lying between say 10 and 30, now what I am doing, I am not only multiplying by say 5 plus say 30. So what happens? Now the range is coming 80 and 180. So instead of 1 to 30, I am now stretching it, right? Only thing that while stretching this, you must ensure that this is less than equals to 255. Now here you observe that I have put gamma is greater than 1. See, why gamma is greater than 1 I am taking, but suppose gamma is less than 1, then you are reducing, you will not get more information, you will be getting the less information, right. So that is why I am assuming that gamma is greater than 1, and gamma should not be negative, because our aim is to, our image is always containing the positive integer values. So we are taking care of that one. Then given a grayscale image, how to get the binary image. Now you have to obviously you have a intensity value lying between 0 and 255, and you have to convert into 0 and 1 image, right. So, some part will be 0, some values will be converted to 1. Now, this some part or some intensity value will be converted to 0, some will be converted to 1, that will be dependent on some threshold value, that these elements, if it is less than this threshold value, you assume that this is 0, otherwise it is 1. How to determine the threshold, that we will discuss later on. So, say if image value is less than or equal to threshold value, you put it 0, otherwise you put it 1, right. So, you get a binary image. Now, this sometimes we need to do the inversion of the binary image. So, this is a simple one, you can be less than or equal to, you put it 1 instead of 0, and the other one is 0. Now, can I get back from binary image to grayscale image? It is impossible, right, because you have already through thresholding you have made them in such a way that 0 is less than threshold value, it is 0 otherwise. So, but you can visualize, you can increase the two intensity level, one is 0, another one is 255, right, based on this statements. But here it will be either black or white, 0 or 255. Now, arithmetic operations on the images. Suppose I want to add the two images, right. First thing you remember, these two images must have the same dimension. Second thing, that once you are adding, I assume they are representing the same objects. If they are not same objects, it does not have much meaning to add the two images, right. Now, second thing is that it is assumed that they are of same size, then they are representing the same objects. Third part is that they are registered. What does it mean? That a registered means that suppose I have in my image I have a house here, and this image also I have a house. So, these pixel position, this pixel positions, this pixel position, this pixel, they should be same. If they are not registered, by adding something you may not get something, get a proper image thing. One way could be, sometimes what we do, I artificially, I want to put here a tree, I want to put a tree here, right. So, one image is having the house, another image is having the tree. If I add, I get a tree plus house. This type of activity also there. People wants to fake something, so he wants to add some operator. But generally, we assume that they are two images same size, they are registered, but for other purposes, so people are using for addition operation. So, addition operation is I x y equals to I1 xy plus I2 xy. Similarly, is the case with the subtraction, right. The subtraction is useful when I want to compare that whether these two images, compare between the two images, or I want to match the two images. So, I will subtract and I will see whether difference is 0 or not. So, this is the addition and subtraction, but you observe, if I add these two, there is a possibility the total intensity value may exceed 255. So, you have to control it, because you cannot add 2 pixels just like that, because there is a possibility it exceeds 255. So, one way is that to control that, to maintain control this overflow and underflow problem. So, you will be putting the mean I1 xy plus I2 xy comma I max, that is what it means, or 255. So, if it is more than 255, then it is 255, right. Similarly, in the case of subtractions, it is a maximum difference between these two and 0. So, if it is coming less than 0, I am forcibly making it 0. Now, once you do it, that basically you are adding the two positive integers. So, what intensity level will be shifting from from one large value to the very large value, right. Say you have 30 and you have 50, if I add, then the value will be 80. So, if my intensity value initially minimum was 30 here and on another image 50, the minimum value will be 80. It is shifting, right, to the larger side, and that is again intensity range of the intensity level will be higher side, but it will not be stretched one. So, in order to do that, in order to cover the whole image, whole intensity levels, what we did, these two add multiplied by the range I want, 255 minus 0. 255 is the maximum intensity value I want and 0 is the minimum intensity value I want. So, I1 plus I2, this divided by the image max values, first image max value and first and second image value, adding after that whatever the maximum intensity value. So, see, I have 30 plus 50, it is 80, another one maybe 50 plus 70, 120. So, maximum of these values will be taken into account for division. Now, once you are dividing, remember the value may not be integer. So, you have to take the nearest integer value. So, the division is very carefully you have to handle. Similarly, subtraction. So, you have subtracted the value multiplied by 255 divided by again I1 minus I2 minimum. So, two image intensity level, what is the minimum after subtraction, what is the minimum that will be taken into account to divide. Is it okay? Not the I1 minimum and I2 minimum, it is I1 minus I2, whatever minimum value that will be taken into account. Is it clear? Now, here also there is a possibility of negation because subtraction is there. So, if it comes to negative value, you forcibly make it 0. The subtraction is very powerful for us because sometimes we want to see whether the two image, if I convert into same intensity level, whether after subtraction I get 0 or not. In reality you may not get it, but this is a useful parameter. Next one is divisions, and the two image I1 and I2 of same dimension and they represent the same objects, then I(xy) is equals to I1 xy divided by I2 xy. I2 xy must be greater than 0, right. But there is no guarantee that it will be greater than 0. There may be a black spot is there. So, 0 division will create a problem. So, what we did, we add some constant to ensure that it is not 0. To ensure that it is not 0. Now, once you divide it something, that number will become very small. There is a possibility, because you are dividing x by y and y, if it is a very large number and x is corresponding x is very small number, then number will become very small. So, what we did, we need to stretch it, right. So, we multiply by some big number, say 255, to get the number again in that range, right. So, you need to do some manipulation here. So, what you have to do, you have to first divide by this, now you get the mean and max, and the same stretching algorithm, you use it to stretch the number lying between 0 and 255. Is it possible? Is it clear? Yes or no? Clear? So, this is first I1 divided by I3 into multiply 255 and divided by I1 by I3. So, this will give the range lying between 0 and 255, right. Sometimes we do the logical operations on the image, right. Generally, this is useful only for the binary image. So, binary image I1 xy and I2 xy, and this is a logical operator, and these are AND or XOR, right. So, this one, that I1 by I3, I by max of this, yes, yes. This is the max of this, yes. Okay. Shall we go to the next slide? So, then A and B, they say OR operator, but these are not that in, see, negation of a binary image, we have already discussed how to do it. Other part is not that important. Now is coming the geometric transformation. So, as I told you that there are several, in any image you will find that there are many reasons to get the geometrically distorted image. Now, you have to correct them, right. Otherwise, your image will not be useful at all. So, this distortion occurs at the time of data acquisitions. For example, as I told you one case that one CCD light is not on. Similarly, while you are collecting the photographs or image face photographs, there may be full of light sources, that total illuminated images. So, it will not be useful, or there is a blurring effect, or the image is rotated, right, because it is not essential that I will get always the frontal and straight photographs. It may be rotated by some angle, or it may be so happen that it is translated or it is scaled. Say I have one image of your photograph, which is I have taken the data from 1 meter distance, and another photograph is from 10 meter distance. So, the 10 meter distance photograph will be very small. So, I need to scale it in such a way that I can compare these two images. So, scaling is an important parameter, right. So, geometric transformations are required to match the two different images of the same subject. To match remotely sensed, I told you this issue, the same idea when after 1 year, what you have to do? First you have to transform it and then you compare it. So, the geometric transform is a vector function T that maps the pixel xy of the original image to x dash comma y dash of the output image. So, x dash is represented by Txy. Tx is your sum transformation with respect to x, and y dash equals Ty xy dash xy, where Ty is sum transformation along the y directions. So, these transformations are either known in advance. What it means? In the case of, as I told you, that scale things, I know that what is your distance from the camera, and so I need to scaling it, or I know that it is rotated by theta angle, I need to correct it, and so on. So, this is known in advance, or I know the original image and the transform image, and I have to correct it, right. So, this Tx and Ty will be either known in advance or can be found from the original image and the transform image, right. One is original, another one is your output image. So, based on that you have to obtain what is your Tx and Ty. So, it has the the geometric transformation consists of two steps. First one is that given xy of the original image, I have to get the x dash y dash of the output image, right. So, that is first part. Once I know the x dash y dash, which need not be the integer coordinates of the output image, I have to estimate now the gray values of the output image or intensity value of the output image. I have what I have to do for each pixel values, I have to get the output image pixel value, right. So, and so on. Now, this estimated by x dash y dash, they are not integer, right. First problem. then once you know these values, I have to get the intensity value of this output image. So these are the two steps. First is that for each image, for each pixel point, you have to get the estimated pixel coordinate of the output in the output image, and then you have to get the intensity value of this. Agreed? So intensity means the brightness values. Now, as I told you that there is a these intensity values, these coordinate values are dependent on these values and the some transformations. So the transformation I am considering it is a polynomial of degree n. Polynomial of degree n, right? So x dash is equals to ark xr yk, and it is a, since it is a x direction and y directions, so it is a, I have written x to the power r, y to the power k, and similarly y dash is equals to this. So these ark, brk are the coefficients. These ark, brk you have to obtain, right? You have to get it in such a way that you can estimate x dash and y dash. Agreed? So these are linear equations. So you can easily have system of linear equations, so you can obtain these things. Now if you see the original image and output image, there are not much changes. Symmetry is maintaining. So that means you do not need to fit a polynomial of larger degree, right? A small polynomial degree is self-sufficient. So degree 2 or degree 3 is sufficient to estimate your x prime and y prime, right? If it is degree 2 or 3, I need to estimate this, I need basically 2 or 3 or 4, 6 or 10 corresponding points in the output image. So if I have to make the bilinear transformation, the x dash comes a0, a1x, a2, ay, a3, xy, and y dash becomes b0 plus b1x, b2y plus b3 xy. This is the bilinear equation, simple formula. So you have the 4 coefficients you have to estimate. Now to estimate the 4 coefficients, you need the 4 coordinates of the output image. If I know the 4 coordinates of the output image, right? If I know the 4 coordinates of this input image, I can estimate the coordinate, I can estimate the value of a0, a1, a2 and a3, right, along with this x dash, y dash and so on. Am I right? See, for these points, if I map to this point, like that 4 coordinates if I have corresponding mapping points, I can estimate a0, a1, a2 and a3. Similarly, b0, b1, b2, b3. Right? That is the bilinear transformations. If I use the affine transformations, this is your a0 plus a1x plus a2y, and similarly y dash equals to b0 plus b1x plus b2y. What it means? That you need to get the 3 pairs of data to estimate a0, a1, a2 and b0, b1 and b2. Now these affine transformations is very useful to make the corrections with respect to rotation, translation, scaling and skewing. So this is clear. Bilinear, these transformations is required to estimate. Now one thing you remember, that these transformations is uniform. Say in one image, for one part is rotated and other part will not be rotated, that is not there. So if I have rotated, so it is across the image, same effect will be there. Now the term Jacobian we want to introduce. The geometric transform applied the whole image may change the coordinate system, because obviously you have the original image, this one, and this is the output image. once you transform it, so the coordinate system will be changed. And Jacobian is a parameter by which you can tell how the coordinate system changes. So, that is important. So, this is nothing but J is nothing but determinant with respect to that whatever transformation you have taken, its partial derivatives. Now, if there is no change, there is a singular, no inverse, then J will become 0. If J is equals to 1, it indicates that it is invariant under that transformation, right. That it is invariant under, say it is invariant to rotation, then J should be 1. That is important, that to prove that it is invariant under certain transformations, you have to show that J is equals to 1. Now, that I have already shown the formula for bilinear, and if I take the derivative and then the determinant, you will find for the bilinear transformation Jacobian value is J equals to this, while for the affine transformation you will get A1 B2 minus A2 B1. So, these are well known transformation, geometric transformations. First one is that I want to rotate the image by an angle theta. So, x dash equals to x cos theta plus y sin theta, and y dash equals to minus x sin theta plus y cos theta. And if you see, the determinant of the value of J will becomes 1. Change in the scale, x dash, I want to increase the scale Ax, and y dash equals to By, and if you see the determinant with J, it will becomes AB. Translation, x dash equals to x plus c and y dash equals to y plus d, and here also you will find J equals to 1, and skewing by an angle theta is x dash equals to x plus y tan theta, y dash equals to y, and J will become 1.